Hello everyone, welcome to Explorer Hub. In today's work example, we'll be finding the Maclaurin series for x squared multiplied by e to the power minus 2x squared. So let's start. The very first thing you should notice is that x squared is already a polynomial, so we don't need to include it in while finding the Maclaurin series. We'll just ignore it for the while, and our main focus would be finding the Maclaurin series for e to the power minus 2x squared. So we know that for a function fx, the Maclaurin series is summation n from 0 to infinity of nth derivative at 0 over n factorial into x to the power n. So basically finding the Maclaurin series would involve us differentiating this function several times and trying to find a pattern, and then we'll substitute in the series. But if you'll notice, this differentiating this function several times would be tedious and would finding a pattern would be difficult. So what we can do is instead is we will start by finding the Maclaurin series for e to the power of x. Maclaurin series for e to the power x. There may be a chance that you have memorized the Maclaurin series for e to the power x, but even if you have not, we will derive it right now and it would be a really quick process. So let's suppose that fx is equals to e to the power x. Then the first derivative of fx would be e to the power x. The second derivative would be e to the power x, and this would continue till the nth derivative. So the nth derivative would also be e to the power x. We know this because we know that the exponential that the derivative of exponential is always the exponential itself. So now we know that the nth derivative of fx is e to the power x, but in this formula we need to find the nth derivative at x equals to 0. So we'll just substitute x equals to 0 and we'll find that nth derivative at x equals to 0 is equals to e to the power 0, which is equals to 1. So now we'll substitute this back into the formula in place of f, the nth derivative of 0, and we would get that f of x is equals to summation n is equals to 0 to infinity, and we'll just substitute 1 instead of the nth derivative at x equals to 0 over n factorial times x to the power n. So right now we were able to find the Maclaurin series for e to the power of x, but in the question we are asked to find the Maclaurin series for e to the power minus 2x squared. So what we'll do is that we will just replace x with minus 2x squared in this whole series. So if we replace x with e to the power minus 2x squared, then it will become e to the power minus 2x squared equals to summation n is equals to 0 to infinity. And here instead of x we will be writing minus 2x squared to the power 9 to the power of n over n factorial. And this now is the Maclaurin series for e to the power minus 2x squared. But if you remember, we were supposed to find the Maclaurin series for x squared e to the power minus 2x squared. So we'll just multiply this function, this series, with x squared, then x squared. We'll multiply both sides with x squared, then we would get x squared summation n 0 to infinity over n factorial. So we can simplify this or make it a bit more cleaner. We would write it as n is equals to 0 to infinity minus 2 power n. We are just separating minus 2 and x squared, and this would be x to the power 2n, and multiplying it by x squared we would get x to the power of 2n plus 2, and the denominator would be n factorial itself. So writing it Just writing it a bit more clearly. So x squared e to the power minus 2x squared is equals to summation n is equals to 0 to infinity minus 2 to the power n over n factorial into x to the power 2n plus 2. So this is the Maclaurin series for the function x squared e to the power minus 2x squared. So that was all. Thank you for joining us. I'll see you all in the next lesson.